Okay, hi all. Welcome to lesson 1 on fractions and decimals. Lesson 1 titled What are fractions? So today's date will be the 5th of the 1st. Obviously, if you're doing them one a day, you can be doing this one on Tuesday. Your learning objective is I can draw, identify, name, and write fractions. You can pause now, have a look at these 3 arithmetic questions, and fill in the answers on your weekly arithmetic sheet. The thinking challenge, of course, is just for you to have a think about. You don't need to answer it. Try and limit yourself to about 3 minutes with this. You can pause the video now. Okay, welcome back. I hope you managed to fill in the arithmetic. Hand in the arithmetic at the end of the week once they're all completed, please. First thing I would like you to do is have a think about this question. So here you can see this square piece of paper. How many fractions can you represent by folding this piece of paper? So again, you can pause the video now. You can discuss with someone. If you are doing this independently, you can have a think about it. Or if you're at home working with a parent or carer or guardian or an older sibling, you can have a discussion, all of the different ways you could fold it to show fractions. Okay, so here are some of our key words today. I'll just give you a second just to have a look through these. Some of them I'm hoping we are familiar with. Some of them we might encounter throughout this lesson. Okay, so a bit of learning about fractions in the real world. Here are some examples of when we use fractions in the real world. Shopping sales that you can see, like half price here. We sometimes use fractions for money, for length, for time. You can see there's a 2:30. Look, for area, you can see a half moon here, or 3/5 of this circle. Or for mass here, you can see like a quarter of this cake has been eaten, or 3/4 are remaining. The glass being halfway full, halfway empty, and of course sports. And you might want to pause here and think about some other times when you see fractions in the real world. Okay, so here are some statements that I want you to pause and consider whether they are sometimes true, always true, or never true. Okay, let's go through them then. Half means 2 parts. So here we have 2 parts, so each of them must be a half. I wonder if you think that is true, always true, sometimes true, or never true. And here we go, we have someone saying you can't have a bigger half. Again, I wonder whether you think that is sometimes, always, or never true. Well done if you identified that this wasn't a half. Just because half means 2 parts, I mean, that is true, but there's a word missing there, and that word is equal parts. Half, of course, has to be 2 equal parts. These 2 parts, as you can see, are not equal. The white one is much greater in size than the red one, meaning they are not equal, so it is not in half. So this guy here is correct. You cannot have a bigger half. Moving on to this girl here. 1 part is shaded and 2 parts are not. So this is 1 and 2 halves. Wondering what you thought about that one. Well, as you can see, these are 1 whole square and it's been split into 3 equal parts. So each of these parts is equal to 1/3, 1/3, 1 the numerator and 3 the denominator. So actually what we have here is 3/3, 1 of which is red, and 2/3 which are white. Here we go again. For this girl here, she's saying the fraction shaded grey can't be the same because they aren't the same size. Well done if you worked out that what you need to do is count the squares. So a quick bit of maths will tell me this array here is 4 multiplied by 6, so 24. And starting from the top here, I've got 3, 6, 7, 8. So now I've got 8 across the bottom as well, is 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 centimetres squared shaded in red and 24 centimetres squared shaded in grey. So even though this may look like one is much bigger than the other, the area of both the grey shape and the red shape are exactly the same, meaning the whole shape is in half. Here are some different ways that we can represent fractions, which we will encounter throughout our journey with fractions in this coming week. A fraction can be part of a whole. So here you see we have a bar model. What fraction of this bar model is shaded in red? Well done if you said 1/6. We can see that the bar has been split into 6 equal parts, 3, 4, 5, 6 there, and one of them is shaded in red, meaning it is 1 out of the 6, so 1/6. Sometimes we might see fractions represented as part of a whole, sometimes we might see them as part of a set. So you can stop the video here if you want, or maybe you can just tell me or the person with you straight away what fraction of this set are shaded yellow. Well, again, well done if you said it's 2/5. I know that my denominator will be fifths because there are 5 things. The whole set is split into 5 equal parts, 5 stars, 2 of which are shaded. So 2 out of the 5, 2/5. My answer there being 2/5. We could also represent fractions on a number line. Now here you can see we have a number line. Now the number line goes from 0 to 1, so the whole number line represents 1. It's been split into 4 equal parts. So what fraction does each of these represent? Well done if you said it was a quarter. Well done. If we can see, it's been split into 4 equal parts, and this is one of those 4 equal parts. So my denominator will be 4, the amount I've split the whole into, and this is one of those 4, 1/4. And a fraction can also be the result of division. Now this will be new to you this year, but what we can see is we've got 3 whole pizzas here, and they're shared equally between 4 people. So we're going to split them between 4 people. So how much does each person get? Well, each person gets 3 pizzas. They get a quarter of the 3 pizzas. So we would represent that by saying the 3 as the numerator and 4 as the denominator. So when we have a fraction like this, where we are dividing a number by a greater number, we can represent it as a fraction where the number that we are dividing, in this case 3 pizzas, is the numerator, and the denominator is the divisor, the number we are dividing by. Okay, this is what your independent task is going to look like. You are going to have a series of fractions like this, and your job is to group all of the ones together which represent the same thing. So you can see some of them are written out, some of them are written as fractions, some of them are circular pizza-like arrays, some of them are number lines, some of them are fractions of sets, some of them are fractions of wholes, all different ways of representing fractions. What you need to do is drag and drop each one so they are all in a group. So for example, I might say, okay, look, I've got 3/8 here. See that, 3/8, 3/8, and I've got 3/8. Oh, my apologies, I've got 3/8 here. I know that 3/8 is one of my sets, so I'll put 3/8 and 3/8, and I will try that for each of them. Can I find anything else where I have 3/8 represented? You will do that on the Google Doc, which I upload onto the next page. So you can pause this video here, and you can, this video will now end here, and you can move on to the independent task.